So what you should have seen in the last couple of slides is that if you have something like x to the power of 4/3, you can write this as a radical by turning this 3 into the root. That number, by the way, is also called the index. And then the 4 becomes an exponent up here. Okay, becomes an exponent on the thing underneath the radical called the radicand. We could also put that 4 on the outside, but I think it's more commonly seen written like this. So what we want to look at now is pretty much just going the other way. Okay, so if I'm given the problem, let's see, the 5th root of x to the 15th power, and I'm asked to write that, or to simplify that. I'm going to write it as x to some power, and the way I can sort of reconstruct that power is by doing the inside number on top of the outside number. See how this was up here? This used to be 4/3, and we went 4/3. So this would be x to the power of 15/5, and then 15/5 simplifies to 3. 15 divided by 5 is 3, so this would really just be x cubed. Okay, that would be considered to be simplified. Now, what if it doesn't work out pretty? What if it's something like the 4th root of x to the 10th? Well, I can still stack those, right? I can still write it as x to the power of 10/4. It doesn't clean up quite as nicely. I could reduce it a little bit. I could divide them both by 2 and make this x to the power of 5/2. And then from there, you've got to really pay attention to directions. If the directions say to write it as a rational exponent, that's what this is. If they want you to write it back in radical notation, meaning it looks like something like what we started with, that's going to be a little bit different. That would be, remember, this number becomes our root, so this would really just be a square root. And if it's a square root, we don't put any number out here. So kind of the default here is a 2. And then this would be an x to the 5th on the inside. Okay, so that would be this same thing, the 4th root of x to the 10th, simplified, written in radical notation. So these two things are really saying the same thing. It just depends on what the directions are saying to do. Okay, and some of these are going to look really scary. You may see some that look crazy like this one. Okay, this is the things that nightmares are made of. But I promise you it's really not that hard. We're just going to start from the inside and work our way out. So I'm going to start with just this, okay? And that, if you recall from what we just learned, we could rewrite as x to the power of 1/6. Then the next kind of ring there would be this. And remember that when there's no number written here, what that really is a 2, because that's really a square root. So that represents a power of 1/2. Okay? And then if I go out one more ring, okay, this is a 4th root, so that would be a power of 1/4. And then if you remember from last chapter, when I have all these powers like this, I combine them with multiplication. So when I multiply along the top there, 1 times 1 times 1 is just 1, so this would give me x to the 1 over, and then on the bottom, 6 times 2 times 4, let's see, that's 12 times 4 is 48. So this would be x to the power of 1/48. Again, if your directions said to write it in a rational exponent, that's what this is. Okay? If they wanted you to write it back as a radical, right, with a single radical, something like that is what the directions would say, ask yourself, well, what root is this really? Okay, a power of 1/48 would be a 48th root of x. Sorry, ran a little short on space there, but that would be how you write it back as a radical. Okay, let's try one more terrifying one. Just for fun. Here's another good one. Okay, so I'm going to start on the inside here. And so what this really says, and people will approach this different ways, but kind of following the same pattern I did up here, I'm going to say x to the 8th And then that very first radical doesn't have a number, so remember there's really like an imaginary 2 there, so that would be a power of 1/2. Okay. My next one, oh, I guess I should color code here, would be this one. And that's another 2, so that would be another power of 1/2. Okay. Then I have a 4th root coming next, so that would be a power of 1/4. And then last but not least, I have this 5th root on the outside. By the way, you probably won't need to actually circle up your paper like this. Okay, yours won't need to be quite as colorful. Okay, so really all of these fractions represent my roots here. This is a 1/2 and a 1/2 and a 1/4 and a 1/5. And then this 8 just came from that 8. Remember that 8 is really an 8 over 1. So when I go to multiply all of these fractions together, that 8 goes along the top and then this 1 goes along the bottom. So if I simplify that down, that's going to be x to the power of 8 over 1 times 2 times 2, so that's 4, 16, 5 is 80. So that would be x to the power of 8 over 80. Let's simplify 8 over 80. If I divide them both by 8, I get x to the power of 1/10. And then again, if I did want to write it back in radical form, a power of 1/10 is really a 10th root. So that would be a 10th root of x. Okay. So again, I know those look scary. They're really not that bad. By the way, once you do a couple of these, you're going to kind of catch on to some shortcuts and not necessarily have to write all of this out. But just based on what we just learned, I want you to see that that's what's really happening there. Okay, is that you have all of those fraction exponents stacked up on top of each other.